Okie doke. So, if GDP and growth is all about technology, then why the great differences across countries? And this has been it was a huge issue in economics for decades. It's kind of a bit fallen off the agenda the last 20 years, I guess. But it was a huge issue in macroeconomics for decades because the idea was like, surely technology, you can freely copy pretty much all these designs for machines and so on. It's available across the whole world. Like in the modern world, everyone has the internet available. It's all there. Why can't it spread super quickly? If technology is the key, why can't all countries quickly come up to similar levels of GDP? And of course, one answer has to do with the cycles of investment. Okay, because if you've got an economy that is way ahead with super sophisticated capital, so we said that capital investment on its own won't give you GDP growth, right? If we're in this economy and we think we'll just save up loads more hammers, that's not going to help. You need these cycles of capital investment which upgrade your technology. Okay, you have to upgrade the technology, but that also requires capital investment. But it's not the capital investment per se that is the key, right? The key is the new technology, which is embodied in the capital. Okay, so if we want to grow fast, if we're here and some other economies are here, like this capital is way more expensive than this capital, right? So you've got to go through cycles of investment with huge investments to upgrade your capital stock and start catching up the GDP. And this is what we see. I don't know if I'm getting ahead of myself here. No, I think this is okay. If we go back to the China graph in the data, yeah, what is China doing here? Okay, China is rapidly catching up its GDP per capita to the US. How is it doing that? It's adopting better and better technologies. So here, everybody is basically in the countryside working in the fields. Not everybody, but the vast majority of the population. Here, they're moving into the towns, they're adopting new technologies for manufacturing and so on. And here, in many sectors in the Chinese economy, it's very close to, or maybe in some sectors even ahead of the US. On the average, they're still a long way behind. So during this time, they've had to make huge investments. Okay, if we look at this picture, yeah. So in value terms, what percentage goes this way and what percentage goes that way? In Sweden, it's like 80%, 20%. Okay. In China and Sweden, that's like a typical modern economy, right? In China, it's like 50-50. Okay. That's what you have to do if you want to rapidly renew your capital stock, improve it, and catch up. Okay. Right, where were we? Let's get back to the notes. So why the differences across countries? So one reason is it takes time to catch up. So even with China, it got onto the growth train, but it still takes many decades to catch up. But then you could say, okay, but why do countries get onto that growth trains, kick off that growth process at different times, and why does it stall in some cases? Like the famous case is Latin America, right? South America. And many of the countries in South America 100 years ago or so had similar GDPs per capita to Europe, for instance. Since then, a huge gap has opened up. So countries can converge, but they can also diverge. Why is that? Okay, we're going to look at three things, three potential explanations: scale effects, O-rings, and investments. So, scale effects, what is that all about? In short, the more people you have in your economy, the more ideas they will generate, and the more growth we will get. Okay, so if you think of a closed economy, not interacting with other economies, okay, technologies, it's like designs for things, right? And the more people we have, the more people there are to come up with new designs. And each person who comes up with a new design, that design can be used by everyone else in the economy, right? If I come up with a pizza, if I make a pizza, well, that's great for me, but it doesn't help anyone else. So if there's 10 of us each making pizzas, or 100, it doesn't make any difference. Okay. But if there's 10 of us coming up with pizza recipes, or 100 of us coming up with new pizza recipes, we're going to have a lot more recipes in the second case, right, to go around. Everyone can use all the recipes. So that's why in technical language the knowledge is non-rival. Okay, everyone can use a bit of knowledge all together at the same time, unlike pizza, which is rival. So knowledge is non-rival, so the more people there are to generate knowledge, the more total knowledge will be generated, and the faster the growth rate will be. But of course, like I said, in the modern economies, that knowledge, it doesn't really help having, if my country has 100 million people and yours only has 10 million, if we compare like Germany and Sweden, I don't actually know the exact population of Germany, but whatever. That doesn't particularly help Germany, right? Because the ideas that people come up with in Germany can easily spread to Sweden. The Swedish ideas can spread to Germany. We're all using the same pool. So what might help global growth is a bigger global population. But historically, scale effects were super important. Okay. So before about the year 1500 of the modern era, there wasn't a lot of communication between different parts of the world. Okay, the ice melted 10, 12, 15,000 years ago, the sea level rose, islands and continents got cut off from each other, people were stuck where they were, they stopped communicating, they stopped sharing technologies. So a kind of hypothesis is when this happened 10, 15,000 years ago, the sort of technological level was roughly the same everywhere because people had been communicating and spreading out from the same base. But then they got isolated in these communities of different sizes. Okay. And in this paper, which these ideas are based on a paper, I think I'll refer to it shortly. Yeah, it's this paper by Kremer, who's another Nobel Prize winner, by the way. He picked out, let me see, 5 different places, right? The smallest of which is Flinders Island. Okay, it's a small island off Australia. The next smallest is Tasmania, south of Australia, or it's part of Australia. But then we have Australia, a lot bigger. Then we have America, or the Americas if you like, much bigger. And then we have Eurasia. So people are communicating with each other to some extent across this whole massive land area over this 12,000 year period. Okay, so there's way more people to come up with ideas here than there are here on Flinders Island, right? So what happened? Well, on Flinders Island, which could support a few hundred people if I remember rightly, they died out. Okay, technological progress was so slow, it actually turned into regress. Because, of course, some ideas will get lost over time. They won't get properly passed on from one generation to another. If there's very, very little generation of new ideas, technology will regress. And that's what happened on Flinders Island. Everyone died out. In Tasmania, not a lot happened. People didn't die out, but there wasn't a lot of technological progress. In Australia, it wasn't all that much better. In America, it was significantly better, but as we all know, it was Eurasia which had by far the most sophisticated technologies in 1500, both in China and in Western Europe and in multiple other places. India, the technologies were way ahead of what existed in America. The American technologies were ahead of what was in Australia, and so on. So this is the scale effect. These days, the scale effect is most important. If it is important, that's debated at the global level. We'll come back to that later in the course, actually. Is it a good thing that the global population is going up? Because then there's more of us to have great ideas. Okie doke. So that's scale effects. So that might explain differences in 1500. But of course, potentially those differences can echo down the centuries and still affect how things are today. But we'll see about that. O-rings. So, one question is, going back to the original question that I asked. Say we get to this position, which we're in 1500 or we're in 1900 or 2000. We've got a country with high wages, high technology. Sorry, I'm going to have to pause. Okay, sorry, I lost track of where I was, but I think I was talking about why technology can't spread. Yeah, so we're in 1900, 2000, the year 2000. We got a rich country with high wages. We got a low income country with low wages. Why can't the people with the capital in the rich countries, why don't they invest in the low wage countries? Set up production there, pay low wages but still a bit more than the going rate, get loads of employees, make loads of stuff, make loads of money. Of course, this does happen to an extent, and we'll talk about whether that's a good or a bad thing as well later in the course. That should be super interesting. But why doesn't that happen super quick? Why don't these differences all even out really fast? Capital spreads across the world, bringing technology with it, GDP evens out. One possible reason is the O-ring hypothesis. Why did the space shuttle Challenger blow up? Okay, what does this have to do with global economic growth and income differences? O-rings. Okay, Challenger blew up because of a faulty O-ring. Okay, it had thousands of components, the shuttle. How important is quality assurance per component in comparison to a car or to a bicycle or to a knife? Okay, if 1 in 100 components are faulty and you're making a knife, well, 1 in 50 of your knives will be faulty. If you're making a bike, in 1 in 100 components is faulty, then a third of your bikes might be faulty. If you're making a car, probably 2/3 will be faulty, say. If you're making a space shuttle, 99% will be faulty. So you need, if you're going to make space shuttles, you need fantastic quality control. And if you don't have that, forget it. You're just not going to want to make space shuttles. 1 in 100 is not going to cut it. You want like 1 in a million or 1 in 100 million. Everything has to be, when you have a huge number of components, they all have to work to a very high degree of certainty. And so if you have trade between countries with different levels of quality assurance, where do you build the bikes? Where do you build the cars? Where do you build the shuttles? Okay, clearly the shuttles are going to be built in the countries with the highest degree of quality assurance. The cars, you still need very good. The bikes, not so much. And like the knives and other stuff, not at all. Okay, not particularly important. So basically, this is why, or one reason why, the high value added, high wage industries, they stay in the high tech countries and they don't move to the low tech, low productivity countries, because we just don't have all the systems. There's too much that can go wrong. Okay. So that's another reason why you can't just industrialize very suddenly in a big bang. You have to do it step by step and build up the systems which are secure and reliable, okay, with gradually more sophisticated products. Okay, so there's 2 reasons why you need to go step by step, basically. One is that taking huge steps is incredibly expensive in investment relative to your GDP. But then you could say, oh, but maybe outsiders can invest. But then the problem is also the more sophisticated technologies. You need a whole series of events. Everything has to go right. If the economy is a bit shaky, you don't have the quality control in place and so on. It's too risky. Okay, so that is the O-rings. This is a long video, but I think we're almost there. Yeah. The videos aren't really supposed to be this long, sorry. The final one is, it's sort of linked to the O-ring. If a country, it's to do with investment. If a country can create a climate conducive to investment, then we can think of cycles of investment with successive upgrading and so on. What proportion of GDP does China invest in capital? 50%. What does Sweden invest? 20%. The Industrial Revolution started in the UK to a large extent due to innovations in making cloth, okay, teak. How could innovations in such a small sector be of such importance? The reason is, of course, that the British already had their empire, they had trade links across the world. So if they'd been a closed economy, the cloth sector would never have grown to be more than about 5 or 10% of the total economy. But with their trade networks, they developed a very productive way to make cloth, high tech. At the time, that sector could expand to be much more than 5 or 10% of the economy and export all this cloth and import food from the other countries. So that way the cloth industry was able to grow much bigger than it would have been able to in a closed economy. And that helped kickstart the whole industrialization process much quicker than it would have done in a closed economy. Okay. But still then, why do some countries join this upward spiral of investment and technological progress while others are stuck at the bottom? The dominant idea of the last 20 years is that it's the nature of institutions inclusive institutions good, extractive bad, which is the key factor. And what determines institutions? Well, your risk is that you can end up with a circular argument that institutions are bad because they've always been bad. One idea which has been very, very much discussed, it's still an open question, is that goes back to colonization. The colonizers in countries where they thrived and they weren't subject to tropical diseases, they settled down there and set up inclusive institutions. In countries where they tended to die of malaria, etc., they set up extractive institutions, like let's just extract as much as we can from this economy, but we don't want to live there. And this is 200 years ago or more, but then these institutions live on, or the effect of that lives on. That's one popular or very much discussed the last 10 or 20 years theory associated with, for instance, Acemoglu and Robinson. Yeah, there's a link there. You still then were left with the question, well, why did the Western Europe and the UK have the advantage in the first place? Why did the Europeans sail to Africa, so to speak, and not the Africans sail to Europe? That's still another open question. Super tricky questions. Oops, sorry, I just clicked on my link by mistake. So, take-home message 4 at the end of this excessively long video: ideas and investment drive growth. In closed societies, more people give more ideas. In the modern global economy, the problem is to attract investment or prevent capital flight and to make good use of it. Okay, end of that video.